When we have changes, either chemical or physical, those are most often accompanied by changes in energy. When water evaporates, so you go outside, it's been getting hot lately, you go outside in the afternoon and you get sweaty and you feel a breeze, and the breeze is evaporating the sweat off your skin. How does that feel? Does it make you hotter or cooler? It makes you cooler. The water evaporating off of your skin is a physical change. It's evaporation going from liquid to gas, but it involves an energy change. It's taking energy from your skin, and that's why it cools you off. It's your body's mechanism to cool you when it's hot outside. Natural gas burning. Why do we burn natural gas? To produce heat. I have a natural gas stove in my kitchen. We turn the burner on to make the water hot to cook the spaghetti, right? Not to cool the house off, but it produces heat. It's a chemical change that produces heat. So the release of energy during a chemical reaction is similar to when an object falls. So here we've got a 10 kilogram weight sitting on the roof of a building, very precarious here. It has high potential energy. You give that a shove, it's going to fall. As it falls and gets closer to the ground, its potential energy decreases, but its kinetic energy increases because it's traveling faster and faster. This is like what I did with the marker over there. When it hits the ground, it has low potential energy, and all that kinetic energy from its motion is transformed into heat. It causes an increase in temperature here because it causes all the molecules in the pavement and in the weight itself to move more, and that increases the temperature. Things with high potential energy are unstable. Things with low potential energy are stable. And what we observe in nature is things tend to go from an unstable state to a more stable state, from a high energy situation to a low energy situation. Just like when you push something off of the top of a building, we can predict what's going to happen. It's going to fall down. It doesn't just keep going sideways. It doesn't float up. It goes down, right? So systems with high potential energy tend to change in a way that lowers that potential energy. Some chemical substances have high potential energy as stored as chemical energy. Things like TNT, trinitrotoluene. That's kind of a tongue twister. That's why we usually call it TNT, because it's kind of hard to pronounce. Or gasoline will undergo explosive chemical reactions in which that stored potential chemical energy is released, lowering the energy of the substance. So things tend from high energy to low energy. So we have words to describe the energy transformation that occurs here. And again, we're using prefixes. Here's exo. When you exit, are you going out or are you coming in? You're going out. We've got exit signs above the doors. Exit means you can go out here. Exothermic means that energy is going out of the system. So in an exothermic reaction, you have reactants that are starting at a higher energy, and when the reaction occurs, energy is released, goes out from the reaction, and the products then have a lower energy. Endo sounds a little bit like in. Endo means going in. It's the opposite of exo, endo and exo. In an endothermic reaction, energy is coming in to the substances. So here you start with the reactants at low energy. They're going to absorb energy from some other source and give you products that are higher in energy. The exothermic reaction is one that's more likely to occur than an endothermic reaction because this is going against the tendency of things to go from high to low energy. Any questions? So let's identify each of these changes as exothermic or endothermic. So water freezing into ice. It's not endothermic. It's exothermic. That one's a little hard to think about. It's easier to think about ice melting into water. How do you get ice to melt? You heat it up, right? You put energy into it. So ice melting is an endothermic reaction. The opposite, water freezing, must be an exothermic reaction. Have you ever wondered or thought about how does your freezer make food cold? You ever think about that? We kind of take it for granted. Our refrigerator freezer broke a couple weeks ago, so that was kind of fun. We lived out of 2 dorm fridges for about 2 weeks. Then you start thinking about stuff. What's going on in the freezer? The freezer is sucking energy out. The compressor, the condenser, the fans are sucking energy out of the inside of that compartment because freezing is an exothermic process. So if you remove the heat, you can get something to freeze. So freezing is exothermic. That's a tricky one. So in the state changes, when you're trying to figure out exothermic, endothermic, sometimes it's easier to think of the opposite. It's easier to think about ice melting than about water freezing and what happens with that. How about natural gas burning? Is it giving off energy or is it taking it in? It's giving it off, so that's an exothermic process as well. Any questions?